So we're continuing on that paper still. All right, because these are questions from the PEP exam itself. All right. All right, so here it is. We are at this one. So it's the old paper from last week that we never finished. All right, so we did the blue one and we started on the white paper. So we are still on the white paper now. We're at question 23.
Sir, I found the answer.
All right, we could talk about it. Let me read it first and then you could discuss your answer. All right, so the question reads, let me see if I could. Can we see this clearly? Are we seeing this? All right, so it says, examine the table below. This is a relationship between each number in row 1 and its corresponding number in row 2. So there's a relationship between this number at the top here and this number at the bottom. This number at the top and this number at the bottom. This number at the top, this number at the bottom. So the relationship is between these. So based on 7, what will be this, since we're seeing the relationship here?
21.
All right, hold on. Let's talk. What is the relationship is what I want to discuss.
Row 1 is multiplying by 3.
Multiplied by 3 to get what's in the second row.
Everybody agree?
Yes,
sir.
All right, good. So
Yes, sir.
all right. So the relationship, let me just write it. So when you're looking back over, the relationship is that the top row, or we could say row 1 multiplied by 3, and it gives row 2. Everybody agree to that?
Yes, sir.
Yes, sir.
Very good. Very good. So let us just put our little conclusion here, because when we're going back to the recording, therefore 7 times 3 equals 21. Therefore, our answer is 21. Very good. Very good. And everybody seeing that very clearly?
Yes, sir.
Yes, sir.
All right. Excellent.
Yes, sir.
All right. All right. This is a little bit pale, honestly. I was trying, I don't know why it was so pale when it copied. But let us see if we can find what it is. Oh, I think I know what's going on now. 1, 2, 3, 4, 5. Okay. I could put on the numbers here if we want. This one is similar to the coin where we want to see how many smiley faces, how many hearts, how many crescent moon. You see what's going on?
Yes, sir.
All right.
Yes,
so if we're talking about smiley face, how many of them are we seeing?
Sir, 1.
2, sir. 2 smiley face.
1, 2.
2 smiley face, sir.
And if you're talking about heart,
3. 3,
that's
sir.
that's an ugly heart. And if we're talking about the crescent,
5, sir.
5.
5. All right. So therefore, we're trying to look at this. So I'm telling you that these, even though it's very pale, you're counting. So you have a 0, 1, 2, 3, 4, 5, 6. So we could focus on the crescent. We need 5. So if you're looking for 5 on the crescent, and I'm seeing a 5 here, so not bad. I'm looking for the smiley face to be 2. So the smiley face, and I'm seeing the 2. And I'm looking for the heart to be 3, and the heart is 3. So this one is correct. That one is correct, so I don't need to look at any other one. Would you agree to that?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
All right, very good. This question again is very similar, Mighty, to the one you answered last week, but it's different, but it's similar. And now we can see. Yeah, we did something like this last week. But it's different. All right, so let's go through. It says the diagram below shows a model of a whole number. Each little box like you see like this in the model has a value of 1. use a model and the information given to answer question 25. Which number does the model represent? So we're saying each of these represent 1. So Mighty, remember when you count up these and you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 10 here. So let me just put a label here. That's 10 along that side. And then let's count go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10 by 10 like the last one. So if it is a 10 by 10, then we are expecting that the total number here would be 100. Everybody would agree?
Yes, sir.
10 by
Yes, sir.
10 would produce 100 here. So that means if this is 100, then that means this one here is 100 as well, right?
Yes, sir.
And so I could put this along the side. Let me put it along the side. So we have 100 there again. And then this is 100 there. And then that's 100 there. And then that's 100 there. So make sure that we're not missing anything. You see that? 100 at the front, then this is 100, then that is 100, that is 100, that is 1. So everybody could see that. So we have, this would represent 1, 2, this is 500 right here. Everybody agree that we have 500 right here?
Yes, sir.
Right, and then this is 10. So we could label these if we want. This is 10. This is also 10. And then this is 5 right here. So we're able to do those. All right. So basically I could take off this now, just for taking off. See. So we have 500 here. Five. Everybody agree that the counting that we would get would be 525 based on the model.
Yes, sir.
Okay.
Excellent. All right, let's go to the other one. Can somebody read that one for me? Please.
May I go?
Go ahead.
Jamie's clues about his mystery number are given below. Use them to answer item 26.
All right. So we're going to read the clues now. All right. The first digit is 1 less than the second digit. All right. So everybody see that clue? The first digit is 1 less than the second digit. All right. So let us open some spots. First digit, second digit, third digit. So we're going to put some numbers here. So the first digit is 1 less. All right, no problem. The third digit is double the second. All right. The third digit is 8. So we're going to have to start off with what we get. Everybody agree? The third digit is 8. Everybody agree to put 8
Yes,
there?
sir.
Yes,
Yes.
sir.
And then we're going to go backwards now based on the clues that we're getting. So in going backwards, if the first digit is 8, then now this is saying that the third digit double the second. That means if you divide this by 2, you'll get
4.
4. And then going backwards, it says the first digit is 1 less than the
3.
yes, it's 1 less than that. So this is 3. Everybody agree to that?
Yes, sir.
All right.
Yes.
All right.
Yes, sir.
Yes, sir.
Okay. All right. Hold on. Hold on, guys. Give me 1 second.
RJ.
All right, let's go. Let's go to the next one. All right, hold on. Let me just verify. Everybody, we say we okay with this?
Yes, sir. Yes, sir.
Yes, sir.
All right. All right, so let's jump to the next question now. Which dot represents the fraction 1/5 on the number line? Observe it. Which one represents 1/5? Anybody wants to comment?
B.
Very good. B is correct. B is correct. So you can know by looking. You can know by looking because
Excuse me, sir, what about C? What about C?
yeah, I will discuss everything with you now. Would you agree that this is 0, right? And this is 5, right? Right, everybody?
Yes, sir.
Right.
Yes, sir.
And would you agree that it's divided up into 5 equal parts? One more. So it's divided into 5 equal parts. Can you see that?
Yes, sir.
Would you agree
Yes,
that
sir.
B,
Yes, sir.
would you agree that B is just 1 out of the 5?
Yes, sir, because 0 out of 5 is not 0.
Here, this is just 1 out of the 5. C does not reach 1 yet.
Mm,
You see that?
yes, sir.
And that's why C is not the answer, because C does not reach 1. And that's why the answer is B, because we're at the 1 out of the 5 spot, and they're talking about 1/5 here. Feel better now?
Yes, sir.
Yes, sir.
All right, very good.
Yes, sir.
All right. Anybody wants to read number 28 for me, please?
Sir, can I?
Go ahead, Mighty.
M and N are whole numbers, and M times N is divisible by 2. Which statement about M is true when N is odd?
All right. All right, so now we're going to have to think, all right? We have a number of things that we want to think about. It says M and N are whole numbers, and M times N is divisible by 2. They want to know which statement about M is true when N is already an odd number. All right, so we're looking at M times N. And when M multiplied by N, you should get an even number. Because if the number is divisible by 2, which means that 2 will go into it without a remainder, then it must be even. Everybody agree?
Yes, sir.
All right,
Yes,
because when numbers are divisible by 2, they are even. All right? So then, they are saying to us that, guess what? N is an odd number. This is already an odd number here. All right? So, what could the M be such that this will be true? All right, let's try some stuff. M must be even. You can try. So you can make an odd number. So let us say you pick 3. Make an odd number, and then you pick an even number here. Can them say N must be even? Must.
Yes.
And then you said, that gives us an even number, right? Right?
Yes, sir.
All
Yes,
right.
sir.
But what you want to do, you don't want to just run away with it. You're testing this statement. So you try an even number here and you get back an even number, which is good. You're going to try an odd number and see. $15. So this is false now. So this would not work, right? So,
Yes,
so would you
that's
agree?
odd.
Would you agree that M must be an even number? And as long as M is an even number, you'll get that. Because what
Yes,
if you
sir.
what if you try 12? 12 times 3 still 36. If you try 8, 8 times 3 is 24. So what we're suggesting here, luckily the first statement is correct. M must be even, because if you try any even number here and you multiply by an odd number, you will get back an even number.
Sir, at odd times, odd would equal an odd number.
Yes, the odd times the odd will give you the odd number. That's why we are agreeing that M must be even. Because M times an odd number, they need an even number for the answer. So in order for that to happen, the M number must be an even number, because as you said, Mighty, if M is odd and then N is already odd, we will get an odd number. So what is the conclusion? M must be even such that this will work. Everybody agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
If you want me to try more numbers, you want us to try like 5 even number with an odd number at the back and see?
Okay, sir.
If you want us to try, watch. Say you're trying 4 and the odd number is any odd number, 5. See that we get 20? And 20 is good. Say you try 12 times any odd number, 9. What will we get?
108.
And you-
108.
and you say that 108 is still even?
Yes,
So-
sir.
Yes, sir.
And if you try 6 times 1, you still get 6. So we can't stop, because you see that as long as you have an even number and you multiply by an odd number, you will get back an even, which is what we wanted here. So we agree that M must be even.
Yes, sir.
All right, very good. So you have
Yes,
to take your
sir.
time when you're going through those. All right, the next one says so we have 2 students, Leah and Carl, each had a piece of cord. Each of them used all their cord to form the shape shown below. All right. So can you see this? Is this clear? Understood?
Yes,
Yes,
sir.
sir.
All right.
Yes, sir.
All right, good. Which is true about the length of Leah's card and Carl's card? All right. So we're talking about Leah's card and Carl's card. We want to know which is true. All right. So they said they form this shape here. Leah's card is longer than Carl's card. Carl's card is longer than Leah's card. Leah's card and Carl's card are equal in length. The length cannot be determined. All right. All right. Now, let's see what's going on here. All right. Let's see what's going on here. When we read, most times we're looking for a particular clue. They didn't give the shape that we used. All right, they didn't give a shape. They said 2 students, Leah and Carl. Leah and Carl each had a piece of card, and each of them used their card in this particular way to form this shape. So based on the measurement, I'm seeing this is 4, this is 4. So it seems like this is going to be 4 and 4 again. You agree?
Yes, sir.
All right.
Yes,
So unless they're trying to do a trick question, if and I don't believe in trick questions. So we're looking at 4 there, you're looking at 4 there, and you're looking at 4 there, based on what they have here, because that is the shape that they said they're using, right? And we will be looking at eight here. So, all right. All right, so basically, we can say this is 20 and this is 16. True or false?
True.
True.
Yeah.
True.
So we're looking at a total here of 20. And we're looking at the total here of 16. So we could conclude that Carl's card will be longer. All right.
Yes, sir.
Carl's card is longer than Leah's card. Everybody agree to that?
Yes,
Yes, sir.
Yes, sir.
All right, good. And you understood how we get the 20, because we said 8 plus 2 plus 8 plus 2. And that's how we got the 20. And this one is just 4 plus 4 plus 4 plus 4. Right? That's how we got the 16.
So you just found the perimeter.
Exactly. So you focus on the perimeter, and because that is the length of the card that you're stretching to form the shape. All right. So the idea is about the perimeter. Right? Exactly. So it's a perimeter here and it's a perimeter there. And you're seeing that you could compare, and that's it. Make sense?
Yes, sir.
Yes, sir.
All
Yes, sir.
All right. All right. Let's look at this one now. So I want you guys to jump at it. Try to figure it out first. Come up with an answer, and then I'm going to butt in. Think about it quickly. All right, can we go now?
Yes.
Let's go for it.
Yes, sir.
All right. We want to go for it. It says though that Mary wants to determine the number of sweets in a jar. Sam gave her some clues. So here are the clues from Sam. So Sam is saying that, hey, the number of sweets in the jar is less than 60. All right. So if it is less than 60, we can go ahead and start to cross out some things. If it's less than 60, then that can't be correct. Everybody agree?
Yes,
Right.
sir.
And another thing, it says that it's greater than 30. That means this can't be in there.
Yes, sir.
Excuse me, sir.
So a lot of times you can eliminate some things very early. So we have two things to think about. So the last clue should help us. A multiple of 3. Well, this one I think is a prime number. All right, a multiple of 3. So all you have to do is to divide this by 3.
Sir, and you get 19 when you divide
Excuse me,
50.
sir.
If you divide this by 3 and see which one works. Go
Excuse
ahead.
me, sir.
Yes, I'm listening.
What was number 29's answer?
Oh, I would have to look back. Carl's card is longer than Leah's card.
Sir, Mary.
Okay.
So this one, the answer is
B.
B. All right, because if we can't divide the 3 into the 59 without a remainder. So we're
Yes,
gonna get
sir.
a remainder. So that means it can't work. So the answer is 57. All right, guys.
Yes, sir.
All right.
Yes, sir.
All right, let us now look at this question. It says, Comart sells pencils for $20.25 each. Very important. Each. All right. Now, approximately how much would 1,500 pencil cost? See that? Everybody see what's going on?
Sir, I did this one before, and I know the answer
Yeah.
Yes, sir.
on my
Yes, sir.
test.
Yes,
And
sir.
the number 23 as well.
Okay.
32, I mean.
All right. They are past papers, so it's possible that you might have worked out some of them at school. All right. So it says approximately how much would 1,500 pencil cost? So you're gonna multiply.
More. Yes, sir, you multiply it.
So everybody, go ahead and multiply this. Depending on how you want to set it up, doesn't matter to me. If you want to set it up like this, that's fine. But you will need to do your multiplication. Multiply all of these.
Wait, sir, I
Yes,
don't need to multiply. I was at the bathroom.
yes, go ahead. Multiply everything, guys. You do your multiplication, right?
Oh, okay.
5
sir.
times 0, 5 times 0, 5, 5, 70, 5, 5, 25, 5, 1, 5, and 2, 7. You just keep doing that. Just do your stuff. Put a 0 here. 2 times 0, 0. 2 times 0, 0. 2 times 5, 10, 0. Carry the 1, 2 ones, 2, 3. And you go again for this one. You'll put a placeholder, and then 0 times everything. 0, 0. You get a lot of zeros here. Okay. 0. My thing is ugliness, so don't watch what I'm doing here. All right, you get a lot of zeros. And then you're going to put 3 placeholders. 1, 2, 3. And then you start this one. 2 times 0, 0. 2 times 0, 0. 2 times 5, 10. Carry the 1. 2 ones, 2 and 1, 3. You get something like that. And you add up everything. This is 0. This is 0. This is 5. This is 7. This is 3. 0. And this is 3. All right, so you do all of that multiplication. And then now you have how many places are decimal? 2. All right, so you have 2 places of decimal. So the answer is 33.75. So they are asking. So when you look at these clues, where would you find it?
Sir, I have the answer.
Where would you
The
find it? I'm in class. Okay. So you're looking at
answer.
everybody will say that you'll pick this for the answer.
Yes, sir. I just saw it. I just worked it out. I finished working it out.
Huh?
I just finished working it out.
Oh, you got the same thing?
Yes, sir.
Okay. All right. Sorry about that. All right. Oh, there's another piece here. You couldn't tell me that there was another question here. Is it? All right, so the other question, so the diagram below shows certain numbers of marbles in a bag. Okay, okay. Half of them are red. Oh, all right. Half of them are red, and the number of marbles in that is the same as the number of. Okay. Can you see what's going on right here? It's like they're representing, it's like they are representing the number of marbles in the bag in a little fraction way, because they are saying red is half. Isn't this half of this shape?
Yes, sir.
And then they're saying that blue and green are equal, which means they're a quarter each. Not true?
Yes, sir.
All right. All right. So let us look. Which of the following could not be the number of marbles in the bag? Okay. Which of the following could not be the number of marbles in the bag? Could it be 96? In other words, it could be 96 because I could get 48
Yes, sir.
and then I could get 24 and 24 and I'll get back my 96 because I'll get half of it and I could take quarter and quarter for the others because they are the same. This, everybody can see that?
Sir, it can also be C.
Yes, sir.
And
It
you're
can
saying
also
that
be D.
we could, very good. You're saying that we could have 26 for the red and 13 and 13. Not true. So, and then we could have 14 and 7 and 7. But we cannot do it with this. Because if we split this into 2, we'll get 39. And you can't split 39 into 2 equal half. When we're talking about marbles. Because we can't have a half of a marble. So the answer is B. We cannot do it with 78. Everybody agree?
Yes, sir.
So sometimes you have to understand what the question is about. So basically this question wants to know if you can pick up what they're saying and then use it to help you to see that all of these numbers, you're able to split it up into 4 pieces and giving one person half of it and then taking the other 2 little pieces and give another. As long as you're able to do that, then that's not the answer because they want to know which number cannot do that. 78 cannot. All right. A bookstore sells pencils at $30 each. Notebooks for $80 each and pens for $50 each. So we are getting some clarifications as it relates to what's going on here and there, all right? Now, 5 pencils, 1 notebook, and 2 pens. So we're talking about, they want to know which combination of items can be purchased using $300. So we're not going to guess anything. We're saying that let's put it together. 5 pencils is $150. Everybody agree? $30 for 1 pencil. 5 pencil is going to be $150. Agree with me?
Yes, sir.
Yes, sir.
One notebook is for $80.
Yes, sir.
And then 2 pens would be $100. When you put this together, don't you realize that it passed the 300 mark?
Yes, sir.
Yes,
As
sir.
it's only $300 you carry. That means it can't work because you carry $300. So if you carry $300, the items must come to less than 300, or at most, it can come to 300 exactly. Everybody get that?
Yes, sir.
All right.
Yes, sir.
So let's go further.
Yes, sir.
1 pencil is for $30. So we'll put our 30 there. 2 notebooks. That's $160 there. 4 pens. That's $200. Now, when you look at this, 200 and 160 already passed the 300 mark. You could not go to shop with $300 and try to buy that. Everybody can see what we're doing right there? So
Yes,
we're eliminating, yeah, man, we're eliminating some things that can't be, things that can't be, we're taking them out, right? We're taking them out. All right. So now let's look at the other one. All right. So we're saying here, 2 pencils, and we're talking about $60 here. Because it's $30 for 1 pencil. So 2 pencils for $60. $80 for 1 notebook. 2 notebooks is $160. And then 3 pens, $50 for 1 pen. So we'll get $150 here for 3. And let us try to, if you put this together, it gone over the $300 again, because 160 and 150 past 300. So we don't even need to check. So that can't work. Naturally, this is the answer. And you know why I know this is the answer? Because if we did not make any errors up here, then naturally, if 3 of them are incorrect, in an exam, I will pick this without working it out, because it has to be the only answer. But let's work it out. 3 pencils, right? 3 pencils come up to what? At $30. So 3 pencils is
$90.
90.
1 notebook, $80.
Sir,
Yes.
we also did this one
Okay, very good. It's very good that you're
on the
practicing.
test.
Very good that you're practicing a lot. When you add up all of this, though, we will get, let's say this is 90, 80, and then 100. We will get $270. Everybody agree?
Yes, sir.
Yes, sir.
So then that's why we're saying that, of course, it could have gone to the shop because you have 300, you would have gotten back change. So we could have gone to the shop and purchased this. So this is the answer. All right.
Yes, sir.
And I hope that everybody is seeing the fact that all of these monies would have gone over the $300.
Yes, sir. I know. That's what I was doing in my notebook when I was doing the test. As soon as one reaches 200 and the other reaches 1, just nope. I
Yeah,
don't even continue.
very good, very good. Okay, you don't need very, very good. That's how you're supposed to work them out. All right, this one is kind of ugly, but let us see what the writing is saying. All right, let me try to read it. All right, no, let me see if I can get it bigger. Let me see. Hold on. Not sure. Hold on, let me see if I can get it bigger. All right, if I get it bigger, all right. We're gonna read that and then I'm going to put it up so we could do the maths. So we could read it. We could read it. It says students were asked to select 1 fruit for breakfast and 1 fruit for lunch. Everybody see that? 1 fruit for
Yes,
breakfast,
sir.
1 fruit
Yes,
for
sir.
lunch. All right, so I'm trying to look to see fruit selected. Okay. Fruit selected for lunch. Apple. Okay, I'm seeing that. Fruit selected for breakfast are, oh, I'm seeing it here. Okay, so these fruits up here are the fruits selected for lunch, and these ones are the one for breakfast.
Dinner, breakfast.
Breakfast. Everybody can say that? Breakfast fruits are along the side, lunch fruits, because see it here, it's telling us, right? So we have to make note of that. Let me just highlight it for us in blue. So this is for breakfast, see it here, fruits for breakfast. And let me put the one for that in green, and this is the food for lunch. All right, so we can see the lunch up here. This is lunch. All right, I can't write so much breakfast there. All right, let's go now. All right, so here, let's hear the conditions that they want, because they would want conditions. All right, so they are saying that, hey, they're saying that the table below shows the number of students who selected each fruit. All right, so these that you're looking on are actually people. These are students all together that selected the various fruits, right? So it said use the information to answer item 34 and 35. So here is item 34. So the question says, which fruit was selected by most students?
37.
Okay, 34 to 37, thank you. Which fruit was selected by most students for lunch? So if we're going to view the fruits selected for lunch, you have to be looking going along this way. Everybody agree? You have to look going down.
Yes, sir.
So
Yes.
the most would have been banana, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
So banana
Yes, sir.
would have been the answer right here. Banana. All right, that's banana. I would have to go back and forth each time now, okay? Everybody understand?
Yes, sir.
Yes, sir.
How many students were in the survey? Let's go back. How many students were in the survey altogether? All right. Now, would you agree that is the same number of students that select breakfast? They are the same students that select for lunch.
No, sir.
Did the question say it's a different set of students that selected? Imagine if you went to school. It says students were asked to select one fruit for breakfast and one for
Lunch.
Lunch.
So
Sir,
let
it's
me
the
ask,
same.
the question. Would you agree
Lunch.
it's the same
Students.
students that select for breakfast, select for lunch?
Yes, sir.
Very
Because
good.
it says students were asked to select
Yes, yes. So then
what they want for breakfast and lunch,
it's
not
the
what
same
they want for
students.
lunch or just breakfast.
Yes. So let us look now to see, watch this, how many students were in the survey. All you have to do is to count up. You can count up the lunch or you can count up breakfast. You will get the same thing because it's the same
Yes,
student.
sir.
So you'll pick on one. So let us count up the lunch. We're going to verify this, do you know? Because how I teach, I want us to see what the point we're making. We're going to verify this and this. We should get the same number. Let's check off. Can we check quickly?
Yes, sir.
150. We're checking the lunch. We have a 150. Then we have a 200. Not true?
Yes, sir.
And then we have
Yes.
60 and 90. Not true?
Yes, sir.
Yes,
All right. 60 and 90 is, this look like 500 to me. 60 and 90 is 150. 150 and 150 is 300. 300 plus 200 is 500. Agree?
Yes,
Yes,
sir.
sir.
Yes,
Let
sir.
us, so it's 500. But let us check to show you that it's the same number. So if you check in the breakfast, watch.